Hi everyone, welcome to the Juvo and Astrafy DBT training. Today, Charles Verleyen, CEO and lead architect of Astrafy, will give you an introduction to DBT. You will learn today the basics of DBT and where it resides in the modern data stack, and the main concepts, and get a higher overview of what DBT is capable of and why it should be used. During the training, it will be possible to ask questions to Charles via the Q&A button in Zoom. You can find it at the bottom of your screen. Charles will answer them during or after the presentation. Then I would say, Charles, the floor is yours.
Thank you, Reinhard. Okay, so hello everyone. As Reinhard just mentioned, this session can definitely be interactive, so I will look from time to time to the Q&A panel and answer your different questions. So yeah, before, like Reinhard mentioned, so I'm Charles Verleyen. I'm a CEO and lead architect at Astrafy, a company I founded with three colleagues, and we focus mainly on modern data stack solutions, so DBT being one of our core expertise. So today, in the coming hours, so the agenda will be split in two parts. So part one will be a bit of theory. So what is DBT? We will really start where does DBT fits into this modern data stack? Why it's useful? Why it's filling a great gap that was not why this tool was really important, and there was nothing in place before DBT. Then we'll talk about a few technicalities, main features about DBT. The main so the core object of DBT are the models, which are basically SQL files. Then we go to DBT properties that are a way to document everything regarding your models and your macros. So we'll talk about DBT macros, which are like a way of bringing like software engineering best practice to DBT using functions. DBT package, maybe one of the greatest thing about DBT is that it's open source, so a lot of people collaborate to it. And that's why we have hundreds of packages now available to use on DBT. And we'll see how you can make DBT aware of data that it doesn't know. So it's through DBT sources. Then we'll tackle the DBT test, how to test your model, making sure that the data that you send, that you expose, is really reliable and curated. We'll talk also about DBT exposures. So that's a way to expose your data, to make it known to the downstream application and the different business stakeholders. Then DBT docs. That's so one of the great things about DBT is that everything that you put in your project DBT will automatically out of the box create a data catalog out of it. And then we discuss some DBT best practice and also the difference between DBT core, that's the open source version, and then DBT cloud. So basically, DBT Cloud uses DBT Core. So DBT Core is really the foundation. DBT Cloud is just a fully managed version that gives you like an ID on a web application. And really, that's a good choice for people that are not that familiar with the CLI, so to say. So introduction. So as I mentioned, I'm the lead architect at Astrafy. We are a professional service company specialized in modern data stack. We are around 10 data engineers / data ops engineers at the moment. So our core business, and also that you can locate where DBT lies into those different data pillars. So on the top here, you have a classical data journey. So it starts with data ingestion, where you can have there are a lot of tools nowadays, also part of this modern data stack like Airbyte, Fivetron, that really make it very easy to have like plug and play ingestion from a source operational database or applications to your analytical database. Then once the data is inside your analytical database, that's where the data transformation starts. And that's the T part of ELT or ETL. And that's really managed 100% by, if you use DBT, you can do all this transformation through DBT in one or multiple repos in a very structured and neat way. So DBT is basically in a one-line summary, is like a big SQL wrapper that provides you a lot of additional features to test and document your data. Once your data is transformed, then it's time to distribute it. So that's really, here we have different use cases for the data distribution. One is, I mean, the main one, the most used one is business intelligence via dashboards. Then we have also machine learning applications, reverse ETL. So that's quite a big topic today. It's really like, okay, you might have found a lot of new insights by transforming your data in your analytical database. You can then feed those insights back to your source systems. And then also a fourth one use case might be API products. So really using your data marts as API projects to make GET requests. For instance, other departments can might need that. Then on top of this, like data journey pillars, we have also undercurrents, like supporting pillars. That's where we also focus. So data governance, where DBT actually can help with that with out-of-the-box data catalog. But data governance is concerned with data quality, data security, data discovery, and law compliance. Then we have another pillar, which is DevOps, DataOps, and MLOps. So that's all concerned with making sure that when you push code, everything is automated. You test your code, so that works as well, of course, with your DBT code. That's what you should have once you move into production. When you do a change, you should have a clear GitOps in place, so that if you make a merge request on the main branch, and you are sure that your DBT code will be linted, checked, and that it will not break anything. And then one of the pillar we do quite a lot at the moment is also like education. We're providing like professional services around education, like DBT trainings, for instance. So that's the core team at Astrafy. I'm on the far left. So we have partnerships with Google Cloud, DBT, HashiCorp, and Airflow. So that's quite a few key modern data stack technologies we focus on. So today, focus will be on DBT. The course objective. So by the end of the afternoon, the idea is that you know what DBT does and its different main features. You know when to use it. You're able to explain the engineering gap that DBT is filling and put really DBT in the context of the full data ecosystem. Know how to start a DBT project. So you will see it's quite simple to jumpstart on DBT and really have tables materialized. So be able to run simple DBT commands to materialize models, run tests, and generate documentation. Those are the objectives for today. So myself, okay, I already introduced myself. Yeah, quite a few experience in data engineering positions. You might also, I will put reference at the end, but I've written a few articles on DBT also. That might be a good reference for your further learning. And I'm, yeah, more than, I'm quite passionate about open source technologies. So like DBT being one of those. What, why, how? So let's start now with our DBT, deep diving into DBT. So why DBT had so much success? Because there are quite some issues with the traditional data stack. So traditional data stack, where we were just writing SQL with maybe like stored procedures, was quite prone to failure. You have long turnaround time to integrate and set up infrastructure. So you're spending a lot of time on infra instead of spending time on things that are more useful for the business, like writing queries, SQL, and getting the insights. So you had slow response to new informations, and the journey to insight was quite expensive, as you needed big teams and some very skilled people on some infra things. So quite simply, the modern data stack, so DBT is part of this modern data stack, is a set of tools hosted in the cloud that enable highly efficient data integration. So modern data stack, so you have might be a bit scary to see all the tools that are out there. So there are hundreds of tools. The idea is that the modern data stack, there is one tool dedicated for each specialty. So for instance, for orchestration, you might have like Airflow. For ingestion, you might have Airbyte. Modern data stack is this set of tools that run on the cloud And the complexity is really integrating those tools together to make them, to have the data well integrated and have really an end-to-end journey from ingestion to distribution. So benefits of modern data stack is really to move from IT focus to business focus. So again, traditional data stack, you might spend a lot of time on the infra, on the very deep engineering things, while the modern data stack tries to move that away and really give power to engineers to really write SQL, get insights, and get value out of the data. So long-term commitments that are replaced with plug-and-play flexibility. So no, it's more and more open source. So you're not vendor locked anymore. You can quickly iterate. Treating data governance as a first-class citizen. That's definitely some data governance has been gaining in traction in the recent years, because yeah, we can more and more, thanks to the fact that we are relieving our engineers from for infra and other low task, we can really start to treat data governance as a more important, something more important. It's easier to implement as well with the modern data stack tools. So here, where the DBT lies in terms of if I have to put like Lego blocks for this modern data stack. So we have the generation of the data. So that's typically your operational database and what kind of applications you might use, like LinkedIn, Slack, HubSpot. All those are generating data. You then use a tool to ingest this data. So the data then arrives in this data storage, so in this rectangle. That's where DBT can start to work. So DBT really starts when the data is inside your analytical database, and it will pick this data, transform it, and at the end you get like curated data marts that are then fed into different data distribution applications. As I mentioned earlier, you have the undercurrents that are transversal and work all along this data journey. So what matters for the business is definitely the data distribution. So that's what DBT makes sure that this data that arrive at the curated data mart tables is clean, tested, and work well. So that the data distribution, then you have the 4 use case, BI, machine learning, reverse ETL, and API product, work on data that is robust and trusted. And so in the end, you can analyze this data properly and activate this data properly. Okay, so today we really see 5 forces that define the evolving technology context. So ease of ingestion, as mentioned, ingesting has never been made as easy as today with tools like Airbyte or Fivetron. Diffusion of data transformation. So that's the key point of DBT, making data transformation as simple as possible and really bringing software engineering best practice into the game. Centrality of the warehouse. So yeah, you bring all your data into centrality. Doesn't mean that you have a monolith. You can have really data products like in a data mesh architecture, but at least all your data is accessible into one place. Abstraction interface. Also, DBT helps quite a lot with that to be able to build the interface that are then as easily accessible by your downstream application. And then last but not least, definitely the democratization of advanced analytics is one of the driving force today in the modern data stack. That you don't need a PhD in statistics or a lot of to be very skilled to be able to run machine learning models. So DBT has also revamped a bit the data family positions. So in the data engineering family, before we had data engineers. That was the only position, so to say, and they were mainly doing like infra, but also writing SQL and doing all kind of stuff. Now with this with DBT, we have seen this emergence of analytics engineers. So those are people that really are focused on data modeling, building DBT models. So those SQL files, so documenting those, testing those, etc. They're really focused on working with DBT, while the data engineers make sure that the analytics engineer can work properly with DBT. So they set up the infra. So if we think about Google Cloud, they set up the Google projects, the data sets, the If you need an orchestrator, then Airflow, self-hosted, or Cloud Composer. They make sure that all the infra part works well, so that DBT can then materialize the models on top of it. Then analyst family and data scientist machine learning family, that hasn't changed. So the analyst family, they are still the ones, the data analysts, talking to the business and in close relationship with the analytics engineer to make sure that the data they require arrives well in the data mart layer. So yeah, that's a bit this split now. So data engineer more like really on the engineering side, low infra side, building the different, deploying the different components. The analytics engineer, those are the ones that provide the lean transformed data ready for analysis, and they apply like software engineering practice to this analytics code, which is really the revolution with DBT. They maintain the data documentation. They make sure that what they provide is always documented and tested. And then the data analysts, those are the ones that are in contact with the business, and then that report, talk with the analytics engineers. So what is DBT? So it's all of those points. It's Python, so it's written in Python. It's the heart of the modern data stack. It's really at the center between ingestion and distribution. It's an analytics engineer best friend, definitely. If you're an analytics engineer today, you should work with DBT because it's widely adopted. It's becoming the de facto tool. It's a community of top-class data professionals. It's also something great about open source in general. That's when it starts to have success. Well, it has like everyone is using it. The community is big, and you just have more and more collaboration, as we will see with DBT package that are emerging at a very fast pace. So what is DBT? Maybe in one sentence, that's really the power of a framework, but not the limitation of a graphical user interface. So with DBT, you have the full flexibility. As a developer, you still have this flexibility of owning and being able to customize everything, to implement like a lot of logic, creating functions, etc. So you are not limited. And still it's very, very accessible. So you don't need to be an excellent Python programmer or anything, because DBT, it abstracts a lot also away from you, so that you can just focus on the SQL if you want. And also, so a lot of the documentation and tests, this is done through YAML, and as we will see later on in the part 2 when we do live coding, YAML is really easy to put tests and description within it. So DBT infers DAG transformations and run models in order. So that's also a big deal in the sense that you will write your SQL. You might end with like 100 model files or 100 SQL queries. DBT will build those DAGs for you. You will know the dependencies, because you will do from another model, and automatically, okay, the DBT knows that if you select from a certain model, then this model needs to run after this one. So you don't need to care at all about the dependency of the models. Between the models, DBT will do that for you. So auto-generated documentation. That's a great thing, because everything that you put in your repository, documentation, test, all your SQL code, DBT will use that to build a data catalog. So this data catalog is actually a first, if you are starting your journey on your modern data stack, you should go first with like this great data catalog that DBT builds for you before moving to like a more enterprise grade data catalog. So what were the core principles that the DBT founders had in mind? It's like really like anyone who knows SQL can work with DBT and start building like data pipelines. The main idea, and this idea is still very, very valid today. So configuration is super easy, and then you just start to write SQL code that you can test and document, and that's just a matter of minutes to be able to start working with DBT. And they wanted to bring, because data for too long been treated as something that you don't test, you don't document, etc. And I think really that's where the software engineering had a lot to bring to the data world, and that's what DBT with this framework is bringing. It's like really like tools, easiness to test, version control, document your data, reuse it. So through the usage of macros, we'll see like functions. Every time you can keep really your code dry, because every time you do something more than twice, well, that's a good smell that you should just write a function. So the DBT community by the numbers, so I think more than 8,000 companies, I think much more today, running DBT in production across 12 databases. So yeah, here, I need to emphasize the fact that DBT is really database agnostic. You know, that's also a great thing, is that it works with any kind of analytical database. Today I will demo and we do live coding with BigQuery, but DBT works with Snowflake, with Databricks, with any kind of analytical database. And if you don't find if there is not yet an adapter for your database, you can make a request, as the DBT is open source, or there is chances are like that there are someone already working on it. So a good thing is that there is a Slack channel also where you can ask the community. So DBT is open source, which means that people can build on top of it. So there are more than hundreds open source package of reusable macros and models. Concrete example, let's say I'm ingesting Google Analytics data. Well, there are a lot of people that have already built models on top of Google Analytics data. You know, like they've built like Kimball, like a star schema with facts and dimensions and like very created data marts. You don't need to redo all this. You can just reuse this package. A lot of engineering has been put into those models. It's really well documented. It's tested. So just reuse it. And this is valid for a lot of common data. Like, okay, if you're using HubSpot data, if you're using Salesforce data, well, there are a lot of models that have already been written. And so good way also to jumpstart and to learn good DBT best practice. So there are 20,000, I think, data professionals that are on DBT Slack. So if you ask a question on the Slack community, yeah, you will get answers very, very quickly. So DBT workflow delivers higher quality analytics faster and cheaper. So yeah, analytics is of higher quality because you can iterate quicker. You can test the data, you can document it. So all this make it of higher quality. Faster and cheaper to deliver, yeah, because you go faster, so you can iterate. Like in software engineering, you know, now if you have a bug or something in production, you can easily create a hotfix, test quickly the change of your models, and then redeploy into production. Open source, so yeah, just one slide I think on open source benefits, because that's really the key, one of the key features of DBT is that it's open source. That's how it became so successful in just 3-4 years. So why open source is leading the game in general in this modern data stack revolution? I think because yeah, when you go open source, you can have a huge community behind it. It's transparent, so you can easily, it takes you a few seconds to git clone, to clone the repository with the DBT source code. And it's Python, you can easily navigate into it. The code is really well documented. Better security, yeah, there are a lot of engineers working on it that are vetting this code. It's merit-based, it's not driven by economics. So people that work on if I start working on DBT on the core repository, it will really be because I want it to be better, more efficient. It's not because I have an economic driver behind it. Yeah, faster time to market, obviously. Okay, and then freedom from lock-in in that case of DBT also, because it's really agnostic to any kind of database, and it's cost effective. So again, cost effective. If you have a team of skilled data engineers or analytics engineers, you can really jumpstart and you start using like DBT core and have something running in production quite quickly. If you are a small team, you're struggling a bit with the CLI and Git workflow, etc., then that's why DBT Cloud might make more sense for you. So here again, it's just DBT core in a fully managed way through a web application with you have an IDE where you can write your query within the web application and so on. We'll discuss more about this later. But this one is like, yeah, it's obviously a paid version, but that's really a very good deal if you're not familiar with CLI, Git workflow instead, etc. Okay, so let's start with the DBT main object, which are the DBT models. So DBT models is the core of anything in DBT. So those are SQL files that contain like SQL logic. That can be, of course, augmented with macros, and like as you see here in this screenshot on the right, the SQL file. You can also have a config block where you can basically give features to this model, like saying, okay, I want it to be materialized as a view or as a table, etc. But basically, then after this config block, it's only SQL as you know it. So why should I transform my data? Why should that's quite a question we should ask actually before to understand really why DBT is required as well. So you should transform your data because you might have to do cleaning. The data that arrive from your operational database, your applications, it can have a lot of columns, fields that you don't need. You can have sometimes that there might be like some garbage in that you receive from your from this operational database and applications. You might want to restructure a bit the data. You might want to filter to remove things that you don't need. And of course, when you arrive close to the data mart layer where you expose the data, you want to do aggregations. The layer a bit before, like in the data warehouse, when you apply data modeling, you might want to join your data, like join Google Analytics data with Salesforce data and so on. So all this actually can be grouped within, like, you need to do data modeling. You need to translate your data that arrive from the source system into like more like business related data that can be really used and modeled and for the business. So everything is a select statement in DBT. So you don't have to do DDL. So you don't have to put like create statement, delete statement, etc. So you will always do like I can just switch my screen if I go in one very concrete, like here, that's a model. So I just define, like, here I have a CTE, a with source, and then I have two CTE, like common table expression, and I just do a select star. Okay, so as you see here, I don't create my table with the create statement, nothing. It's just SQL. So that's DBT actually behind the scene will do the DDL statement for you. Okay, and just checking. Sorry, okay. So I'm just checking here the Q&A regarding the data catalog. This is a way to check on dependency even with rename or only table dependency. So at the moment, it's just table dependencies. So DBT doesn't handle lineage at column fields yet. So for that, if you really need that, that's a good reason where you would need like a more advanced data catalog solution, for instance. Or like, for instance, in BigQuery, as we will see later, BigQuery also does lineage at fields level for free. So everything is a select statement in DBT. So you just write your SQL. DBT will handle the DDL, creating the table for you behind the scene. Idempotent. So if you give the same input, you will always have the same output from your models. You can materialize models with different configurations. So that we will see also. So that's definitely one of the key features of DBT is that you can pass configurations to your models. So like how it should materialize the table. You can pass tags to your tables. You can pass hooks, like things that has to run after your model has run, and so on. Let me go back into the slideshow mode. So DBT generates the DDL at runtime, as I mentioned you. So you would the DBT model, it will look like something here on the left. So select star from a table, and then DBT would then wrap that into a DDL statement to create your table. So you don't have to take care of it. So DBT supports several materialization strategies. So materialization, so that we are clear, is really how DBT will take your SQL code, your models, and put it in your analytical database. So how it will materialize it. So it can either create a table, it can create a view, ephemeral. So that's something that will just stay in DBT. That just, if you have like, imagine you have a huge file, like a huge model file, like more than 300 lines. DBT recommends there, it's also like software engineering best practice to split that file into smaller files. So you can have like ephemeral files that are just like CT, common table expression, that are then just called in another file. In the end, those ephemeral are just like just a way to decouple a big file into many files. Incremental, so that's if you are handling big data, you don't want every time you run DBT to transform all the data. That's a way to tell DBT, okay, if I run my transformation on a daily basis, you can tell DBT, okay, just take the data from the day before, okay? And then of course, materialization, you can also build your own. So for instance, in BigQuery, there are like materialized views. So this actually, chances are, again, someone has already built that kind of materialization. For materialized view, for instance, that's the case, but it's just not built. You will have to import it as a package. And we'll see that after, how to import stuff that are not present by default in DBT. So the ref statement, great thing also about DBT is that you don't have to, so a table ID normally is made of like project ID, database, schema, and table ID, okay? You don't have to hard code that in DBT because DBT has the context about everything, all your models. So you can just reference, if you do a select from, you can just put the ref of another model, and then DBT will automatically build the good table ID for you. So that's the example here. So my order.sql, it's referring the base orders. So I'm doing a from ref base orders. I can see here on the right that DBT has compiled the code and put like instead of ref base orders, it has put the ID, the good ID of the table without me having to tell DBT what was the project, what was the data set of the table ID. DBT knows because it has the context about all your models, and it exactly knows how to transfer that, how to translate that, sorry. DBT properties. So once you have written models, so you would start by writing a few models. Those are materialized. That's good. But then idea is that you start to document those models. You can see the DBT properties are basically YAML files. So you can have like one YAML file per model. That's one way of structuring it. Or you can have one YAML file where you put the description of all your models. That's a way of seeing it. And in those YAML files, so you will basically, as you see here, put the name of your model. So that's the table name. Then you put the description of the table, and you can go like put all the columns, putting like the name of the column, the description, and test. You can easily, we'll see test more in detail, but you see that to test if the column is unique or not, doesn't contain any null values. That's really like 3 lines in the YAML file, and behind the scene, DBT will run those tests for you. So configs, so we really need to make the split between configuration and properties. So properties are really like informal, okay? So properties really YAML file, those are descriptive, and they will be rendered in your DBT data catalog. Configuration, that's really more, for instance, the materialization of your table. That's a configuration that will tell DBT how to materialize your table. Tags also, like or hooks, like you can also have hooks that run before your DBT before your models, after your models. So configurations are more things that DBT needs to be able to work. And these configurations have default values. So by default, for instance, materialization by default is always a view. So if you want a table or something else, you have to explicitly tell DBT via this config block. So yeah, that's what I just said. So configurations are they can be defined at different places. So either in a config block within the model. So that's here on the screenshot on the far left. They can be also defined actually in YAML, but that's not recommended. So you would go either with the config block within the model or at dbt project.yaml. So dbt project.yaml is quite well, the master file in your dbt project, and there you can put a lot of configurations. Something important to note, and we'll see that in details when we go to the live coding. If you have materialized, you can have like a default materialization in your dbt project.yaml. And then you can have, if you put a different materialization within your model, so within your the config block of your model, what's closest to your model will take precedence, okay? So here, for instance, materialized table, the model will be materialized as a table, even if it has materialized views in the dbt project.yaml, okay? So it's really everything that's the closest to the model will take precedence. dbt source, let me check if there are some questions. Okay, no. Sorry. So DBT sources. So DBT knows once you start writing models in DBT, DBT will know, but it will be in this context itself. But there is something that DBT doesn't know. It's like really the raw data, the source where it has to start from. So that obviously DBT doesn't know. So you have to provide this information to DBT, and you do so by with the source file. So as you can see here, source, you can say like. Where that's basically definition of where is located, where are located your different tables. So here you have like this data from Jaffle Shop. You might have data from Stripe. You might have data from raw data from HubSpot, etc., etc. So source make it possible to, so of course, that's the entry point of DBT, but you can also like document those source, you can test those source, you can put data freshness also on it. That's a very good use case, because you might want to say, okay, I only run DBT if my data, if the new data I received in my raw tables is fresh enough. So for instance, did I receive data since yesterday? And all this you can define also in DBT. So as you can see here on the left, that's the source definition. You have like Jaffle Shop and Stripe, as we said before. And then in a staging model, so like the first models that will use the source will be defined in your staging folder if we abide by a data layer structure. Oh, sorry. And then here you see you select from source Jaffle Shop orders, and automatically, as you see below, DBT will compile into like raw Jaffle Shop.orders. So it will put the good table ID. And left join, so as you see, you left join with the two tables that are present in the source, and DBT can compile successfully. Source properties, test, and freshness. So source, like any other resource, can be documented and tested. So that's and that's highly recommended that you document your sources as well, because actually that's the source is really like the layer between the data producers, so the operational database and the applications, and then the analytical database. So that's really, if something goes wrong, it's always like we go into the raw table and we can see it's important that each field is well described. So that's how you can communicate then well with the data producers. So DBT can snapshot the freshness of the data in your source table. As I mentioned, yeah, that's really useful to see if your data pipelines, if your data producer has dumped data recently. DBT macros. So that's one of the software engineering practice that that DBT has brought into the data game. So it's really making sure that if you do something more than twice, that's definitely a smell that you should create a function around it. Okay, like you shouldn't repeat your logic through all your SQL files. Just build a macro around it and then use this macro in your SQL files. So here, for instance, we have simple macros that just sends $2. It will take a column name and then divide it by 100. Okay, Using GJA turns your DBT project into a programming environment for SQL. So these macros and this function, through that you can use control structures like if statements and for loops in SQL. You can also use environment variables, which is really cool because then you can, depending on which environment you are, either dev, sandbox, QA, or prod, you can have different environment variables set up, and DBT will operate differently based on those. You operate on the results of one query to generate another query, abstract snippets of SQL into reusable macros. These are analogous to functions in most programming language. So macros are really equivalent to functions. So when you create a DBT macro, it's like if you were creating a Python function in Python. So macro, here you have the definition of macro on the top, and then you have a model here that use it. So you just call a macro like with this double curly braces, cents to dollar. Here the macro is expecting one argument, which is a column name. So you pass here the amount. And then you see here on the right, when it's compiled, that DBT is compiling the macro into something that will be then used by your analytical database. DBT exposures. So again, so everything that happens before the data marks layer, that's really things that are internal for data engineers, analytics engineers, like to prepare really like to prepare the data to be exposed. Once the data is at the data mart level, that's where you want to make the business, the downstream application aware about it. And DBT has this concept of this feature called exposures. So you can see here in green, that's the sources. Then I have my staging models. Then I have my intermediate where I do some joins. And then I'm getting to my data mart layers where I finally create an exposure. So this exposure is basically probably like a dashboard, and it's joining those three, my two DIMs with this fact, okay? And that's a way to just checking if I have, okay, no. Then why is that? So DBT introduced a concept that's really a game changer with version 1.3 is the semantic layer. So what you had in the past, what you still have a lot at the moment, is that you have like different departments that are that, for instance, wants to compute the revenue. Okay, so they go into your analytical database, and each one of those can reinvent a bit the wheel. You know, like I mean, revenue is a basic metric, but it might be that the notebooks guys have a different value than the catalogs ones because they have used a different logic because they wanted to make it on their own. What DBT introduced is really this semantic layer, which is a metric store. So you defined some key metrics there. So on the same level as the data marts. For instance, the revenue, you would define in your YAML file, okay, what's the revenue metric? And then a downstream application would not have to implement the revenue logic. They would just consume this metric from the semantic layer. We'll see like a concrete example in the live coding. Of course, tools need to be able to integrate with this semantic layer, which is, as you will see, I can already show you how it looks like. So for instance, revenue.yaml. So you would define, again, no SQL here. That's the cool thing about this metrics. I define, okay, my metric, it's revenue. It references a table with orders. What's the calculation method? It's a sum on what? On a field that's called amount. And then I can put, okay, dimensions where people can use with this metric. I can also define a timestamp field, and then so basically people will be able to use this revenue with those dimensions and with this timestamp field. Again, zero SQL here, and then this can integrate with downstream applications. So there are a lot of integrations already, like with Athlon, Vertex AI, Azura, Looker, and so on. Okay, so DBT packages. That's as I mentioned at the beginning. So DBT It's open source, meaning that you can build on top of it. And there is like a DBT hub where there are a lot of packages that have been built by the community, but also by DBT Labs. So DBT, the official company, is also contributing and building a lot of very created packages. So a few packages to use. So DBT Core, of course, comes with the core functionalities, but then on top of that, you have like DBT Utils. That may be the mother of all DBT package. It contains really a lot of macros, basic macros, you know, like things that you might take you like half an hour, 1 hour to do in SQL. Well, DBT Utils has already all those macros, all those logics into well-curated macros. We'll see examples afterwards. DBT Project Evaluator. That's also a package that's maintained by DBT Labs, and that gives you out of the box quality metrics about your DBT project. Okay. Again, installing package, you will see it's one line. Show you here. Then we will run the command together. But if I go into, there is a package.yaml. You just need to do like this. You put the package version you want to use, and then we will run DBT deps to install. Very, very easy. DBT Project Evaluator, so you just install it. It runs behind the scenes. So every time you do a DBT test, DBT Project Evaluator will run and gives you like warning about some things that you're missing, some best practice that you're missing in the DBT project. DBT Profiler, that's a cool one also. It's for each of your models, it gives you like a profiling statistics that you can add then as documentation to your profile, to your model properties. DBT Expectations. So DBT comes with a few built-in tests, but then DBT Expectation is a package that includes much more tests that you can take and reuse. Then, of course, your property files. Normally, you start by writing models, so SQL files, and properties files can be quite time-consuming to create. So DBT Invoke generates like the skeleton of those files. So it will check in your query what are the final fields, and then it will already pre-build like the YAML files with the good structure, and you just have to fill in the description and put the additional tests that you want. DBT Unit Test. It's a cool DBT package that allows to mock data, because sometimes you don't want to run tests on all your data. You just want to test like maybe a specific part of logic of your SQL, and then DBT unit testing will show you a demo also during the live coding. It allows you to mock some data and really run tests in an isolated way. DBT model usage, very interesting, because it will give you statistics about how your models used, you know? Like sometimes you might have like 100 data marts, but actually maybe only 20 are used, because yeah, the 80 others were asked one day, but then no one used those. DBT model usage, we really like, it will query the metadata of your analytical database to see, okay, has someone really done a select query on my end tables. DBT Elementary, that's an observability package, very interesting. I'll also demo this one because it gives a UI on top of your test. Okay, so it's really it will take all your tests and put those into your UI so that business stakeholders and anyone can easily navigate and see if the tests have passed or failed. Yeah, so that's the focus here on the data observability package. I've just done a specific slide because I will demo that during the live coding session. So here, yeah, high overview architecture. I've put that slide just for you to understand how package work in general. So elementary, that's the architecture of the elementary package. So it works for you. You don't need to actually to understand to have an idea about this, but that's good to see how package under the hood works. So elementary package, you will install it via your package.yaml, and every time you run, you do a DBT run, DBT test. Every time you do a DBT action, elementary will run as a hook like after you DBT runs, and populate some tables. So again, tables that are in an isolated data sets, and those tables then will contain metadata about your DBT project. Those tables are work in incremental, so they are not. That's good because it keeps history, and then the CLI, the elementary CLI, so the reports that I mentioned, like this UI, will then connect on those tables and display then nice UI dashboards. And it also has, like, for instance, in this case of elementary, it also has like alerting features, like sending alerts to Slack, email, and so on, or firing a message to PubSub. DBT tests. So once you build models, like in software engineering, everything you do should be tested. So same here, your data should be tested. You shouldn't go like 100% testing, but you should go first with the fields and the data that is really problematic. You know, like the business always complains about a specific dashboard or something failing all the time. That's where you should put your focus and making sure that those things are really tested, and you should always test the most left as possible, so at the source, so to say. So that's also a big topic at the moment with data contracts, that you should make sure that that data that comes from your producer, even before it reached your analytical database, it's already like complying with data quality. Built-in framework for testing your models. So tests are, so tell you, as we will see, there are singular tests and generic tests. So there are tests that you can use as is out of the box and put them in the YAML file of the model. And those tests then just get compiled in to SQL by DBT under the hood. And you can also check, the good thing is that you can check the SQL that DBT is building to run those tests. So every single test that you write, not only the built-in, is SQL. Behind the scene is SQL code. So out of the box, DBT has four tests, four generic tests. So to check if a field is unique, if it doesn't contain nulls, if it only contains certain values, or if it's a foreign key to another table. So you can test anything that can be written as a query. So it's quite flexible. So two kinds of tests. So singular test is basically a SQL query. Okay, here I'm checking order IDs that don't have a total amount greater than 0. Okay, basically a test fails if the query that's behind the test returns some results. So if I have rows that are returned by this SQL query, that means my test has failed. And tests are run by the DBT test commands that we'll see. So generic tests, so idea is that you don't write too much singular tests because you want to keep your code dry and have stuff that are generic. So generic tests are like macros functions that can be reused. So for instance, like as I mentioned, so DBT comes with 4 generic tests already, so that you can define in the YAML here. So in the property file of your model. So here, for instance, you have your model orders. It has a field that is called status. And the status field should only contain the following values: placed, shipped, completed, returned. So DBT will run a test behind the scene, and that is SQL code, and it will make sure that those values are, if there is another value other than those 4, then it will fail. DBT docs, so that's again out of the box, built in DBT. You have nothing to do. It takes basically every time you'll have to run a command to generate the docs. We'll see that, and DBT will fetch all the information, metadata it can find in your project. The description from the YAML file, model dependencies, the SQL from your models, information about your source, test. It will take all this and build a data catalog that is quite user-friendly to navigate through. So not only that, DBT will also request, get metadata from a analytical database. For instance, in BigQuery, you will get information from the information schema. It will get stable statistics and so on. So we'll show that in live, but that's how the DBT data catalog looks like. So you have, of course, like a normal data catalog where you will see like a description, data types about your columns, you row SQL, and then you compile the SQL. So it's quite convenient so that you can copy paste the SQL and test it in BigQuery. And then you also have this lineage graph. This lineage graph is really helpful when you want to debug, refactor, or because, for instance, okay, imagine you have a big spaghetti, you have like hundreds of models, and you want to see the dependency from which model the data comes from. It might come from like 5 or 6 models. That's a good. That might be a good model to refactor. And the good thing also in this lineage, you can see with different colors that, like, for instance, the green rectangle are the sources, the blue ones are just the intermediate, the normal models, and then the purple one is the exposure, or the exposures. So you will see, as I mentioned, you might have DBT projects that are quite big, where you have like more than 100 models. You don't want to, so you don't want to run everything all the time, you know? You might want to say, okay, I only want to run my staging models, or I only want to run my models related to finance and so on. So that's why DBT, so DBT allows you to have a lot of flags that allows you to filter. So in the command line, you would do like DBT run, select. You could select models individually. You could select models by tags. So you can tag model, and then you can say, okay, tag nightly. So that would run all the models that have the tag nightly. And then you can, every time you have a space, it makes a union. You know, like here it will run all the models with tag nightly. Then the model might name my model, and then all the model within the finance base directory. And then again, so the selecting features are quite limitless. But if you start using this select via the CLI very often, always for the same filtering, then it's recommended to put that logic into a YAML file. So into a selectors.yaml file, you will put your selection logic there. It's quite easy also. You will define like, okay, union, intersection, what method, what value, etc. So that now, if you want to run like this big logic of nightly diet snowplow, you know, that's the name of my selector here. You just have to do like, to put the flag selector and then run nightly diet snowplow. And then it will run, DBT will only run the models that satisfy the logic that you have defined in there. So DBT project structure, again, like in software engineering, it's very important to have like modularity, like to have a good organization in your folder. So basically, a project will always be like you have this DBT underscore project.yaml file. It's a bit the master file. And then you have a folder with for your models, and then there you have like different subfolder per data layer. Okay, sorry. So you have different subfolder per data layer. So here we are focusing on the, so you have staging, you have intermediate, you have data marts, and so on. You can have like, depending on the data layers that you have. Sorry, maybe a few issues. Okay, so again, I will share the slide with Reinhard. Will send you the slides to all of you. So here, but so a lot of text here, but I will just keep that slide because all those guidelines have been really well defined into my DBT labs. And what's recommended? So to summarize, it's really to have like 3 subfolders in your for your DBT project structure: 1 folder for staging, 1 folder for intermediate, and 1 folder for marts. So again, staging and intermediates should be abstracted away from end users, and that's really only the marts models that are really exposed and that your end users will consume. data engineers, analytics engineers, they work on the 3 data layers. Wait, just my browser that keeps on asking me. Just 1 second, I need to. Yeah, that should be good now. So if we look at the staging, when you structure your DBT project, the staging data layer, that's really where you do like basic transformations. That's really, that's the layer that will fetch data from the source, from the raw data, and apply like very basic transformations like renaming, typecasting, basic computations, categorizing. It's always one-to-one with a source table, with a raw table. Okay. You shouldn't do joins and you shouldn't do aggregations at this stage. That's really important. That this is really like a first cleaning transformation. Intermediate layer, that's where you apply data modeling. Like really, like if you want to apply data Vault 2.0. If you want to apply dimensional modeling with facts and dimensions, that's where you do it. That's really where you take all the data from staging. So again, intermediate layer starts from the staging layers. You take the data from this layer, and you apply. You can join it together, etc., to get to translate it into some more like into a data model that will allow you to serve a lot of use case for the data mart layer. So again, not exposed to the end user. You isolate complex operations, and the idea is that you structure also by data product here by domains. Okay. So something important also is narrow the DAG, widen the tables. So it's at the beginning at the far left. So at the source, you have obviously a lot of tables, and the idea is that the more you move to the right, the DAG should narrow. You know, you should start to have wider tables and less tables. Finally, the marks layer. So again, group by department or area of concern. That's the idea of having data products. So you have like finance, marketing, and so on, and that you can really expose tables that relate to those business concept entities into a logical family. And then by entity, so build the same concept differently for different teams. Yeah, that's something you absolutely want to avoid, is to have like similar tables, like duplication of code across different data products. So if the marketing needs, for instance, like revenue or like finance data, it would just take it from the finance data product that will have exposed and it can use it, but it shouldn't rebuild it. So the idea is that the data products, like between the different marts, you can, and between even any kind of models, you can join and use data from other models. Sorry. So materialize the tables or incremental. Yeah. So in general, if you can use the incremental materialization for a model, you should always do it, because incrementals basically it's the most complex materialization, but it's really the one also that will be the most cost effective, because you will always take the data that only the data that you need, the recent data. Then the data marts, yeah, it's really a good practice to have them wide and denormalized. So instead of so that people from the downstream application, they shouldn't start to do joins and so on. They just go to one wide and denormalized table that has all what they need for their use case. Yeah. So for the rest of the projects, configs per folder or config per model. So yeah, that's what you can have one property file, one YAML file per SQL, or you can have like one YAML file for many SQL. It's a bit, there is no wrong or good approach here. It really depends on you. Cascade configs, as I mentioned, you can have like default configs in the DBT project.yaml file, and then you can have like if you want to override that default config, you can put it then in the config block of the models. If you have like small mapping tables, those should be like built as seeds. We will see that with the live coding sessions, that seeds seeds are perfect for training session when you want to load share data in CSV, and then people can easily start using DBT with those files, and they don't need to have access to external data. You should never use seeds in production for loading, like for instance, source data. You should then use a dedicated ingestion tool. Okay. Yeah. So macros, as I mentioned, you should, every time you see that you are using the same logic in different models, that's a good smell to build a macro. So some DBT best practice here. So as mentioned in the staging data layer, you should rename and recast fields only once, and it's in that data layer. You should not do that afterwards. So, for instance, the staging is also, if you have like fields that mean the same things across different data source. I don't know, customer can be like customer in one data source, customers with a S in another one, customer ID, like, you know, all these things. In the staging, that's a good, that's where you should like rename everything to be consistent, you know, afterwards. Only reference raw data source, raw data once. Again, like only the staging should select from the raw data, not the other data layers. Consistent SQL, very important. So, thing with this SQL is that it's very accessible. So that's a good thing, but that's also a bad thing because it's easy to write bad SQL that will work. So that's why you need, like, there are tools like SQL Fluff, for instance, libraries that are like that can lint like linters for your SQL. So dry code, always think about keeping your code like dry and to not repeat yourself. Splitting up large models into a smaller piece, use of ephemeral. Rule of thumb, every time you have like a model that is more than 100 lines, that's a good thing to refactor it into smaller ones. All models and fields documented in YAML files. So yeah, you should document everything. Not at the very beginning, but you should create like Jira tasks and stories to document everything, every one of your models. So you should also, of course, adopt widely testing your models. Naming convention is very important. If you start having like, if you're working on a big data project, then it's a nightmare if you don't have clear naming conventions used by everyone. And you can also enforce those naming conventions through continuous integration pipelines, which we'll discuss later on. Using reference source, that's quite obvious. You don't want to hard code table IDs. So by using reference source, DBT automatically manage the context and the table IDs for you. Organize your directory, as I mentioned. So data modeling, that's also something very important, is that DBT is an excellent tool, but it won't do some of the basic job for you, you know, like data modeling that has been there for many years. DBT is not, it's not that it cannot do it, it's that it's not something that technically can be done by a tool. You know, it has to be, you know your data, and you have to know how to split it into data products that make sense, how to what kind of data modeling technique makes more sense. Should I go with a complex one like data vault 2.0 because my schema are often changing and I want full historization, or should I want to go with an activity schema model? All these kind of things. DBT can run any kind of data modeling approach that you will choose, but the real data modeling, like this needs to go through workshops that you do at your company, and that end up then translated into models in DBT. So data mesh, it's again a buzzword, but think about like breaking your DBT, because you might start with a small DBT project, and then it will just pile up. Models will continue to grow, and then you might end up with this kind of lineage graph, which is very, very difficult to read. That's a bit. We can take the comparison with like a monolithic code base in software engineering, where you have like everything in one place. It's really hard to jump in to understand. So if you have new analytics engineers, yeah, good luck for them to go in there and try to make sense of this. So like here, you lose a lot in velocity because every time you want to change something, it's difficult. So if you start to have like once your DBT project starts to grow, there will be a point where you need to break it into multiple DBT projects. And again, you're not going to lose anything by doing that, in the sense that you will still be able to join between your different DBT projects. So your DBT projects will just be considered as a package. So if you want, for instance, let's say I have a DBT project for my finance department and a DBT project for my marketing department. So those are like two data products. The DBT project of marketing can easily make a join with a model from the finance DBT project by just importing the package. So like by importing the DBT project of finance. Okay, last point, last topic before we do a small break and we go into the live coding session. Oh, sorry, the title is not good here. Cloud. So DBT lowercase also. A lot of people make the mistake. So DBT core, it's open source. Yeah, it's so as you will see in the demo I will do afterwards in the live coding demo. Configuration is quite straightforward. You need to obviously to know a bit of CLI, so the command lines, and GitHub's workflow, Git workflow. But apart from that, it's quite really easy to use. Still, DBT core won't provide you with orchestration, for instance. It won't provide you with logging and alerting. It won't provide you with a single sign-on to use your DBT code and so on. So, because obviously when you have DBT, when you have models, you want to run them at a certain schedule, okay? So the approach, if you want to remain like open source, is to run DBT through, for instance, Airflow. So you would go, I can show you that, for instance, us at Astrafy, we have, Airflow. So here I'm going to show you, for instance, we have a FinOps data product. And the way, so we want to run it every day. So we run it through Airflow and we run it like, okay, the staging models in one task, then we run the data warehouse models, then the data mart, and then we publish a message that will be read by downstream application that will then dispatch, that will then use this new data, okay? So this is, in case you use DBT core, well, you need to set up as well an orchestrator, like for instance, Airflow. Logging and alerting, also like in DBT core, you need to set up that apart for your models that run. So that's what DBT Cloud offers on top of DBT core. So first, it offers like it's a SaaS, it's a fully managed experience. You don't need to install like a PyCharm or Visual Studio. You will have an IDE integrated within this web application. You will have an orchestrator that will orchestrate your jobs. You will have logging and alerting embedded, integrated documentation. Yeah, I mean, the DBT core already has that also. It's just that you need to build your data catalog with two commands. But there it will be like more integrated into this web application. And then yeah, to access this web application, you have the classical user auth SSO. So I always recommend start with DBT core because DBT Cloud use DBT core, obviously, like the code base, the main code base is DBT core, is open source, and then DBT Cloud use that. On top of that, it just adds things that are not it adds supporting activities, so to say, to DBT, like orchestration, logging. So start with DBT core, start small with that, and then I think DBT Cloud it has a free tier, so you can easily play with it for free. And otherwise, I think it's $50 or $100 per person, depending on the tier you use. Okay, closing thoughts on this theoretical part. Like everything, DBT to reach like to perfection, it's a journey. Yeah? So you will once you start implementing DBT at your company on whatever project, first you have no DBT, then you will start with doing like DBT run, DBT tests on really easy commands to get familiar with it. That's what we will start with in the live coding session. Then like the toddlerhood is like, yeah, you start to use sources, you start to have more tests, you start to document, you start to use built-in macros. And then you have the childhood when you start to have like a basic deployment into, you might have like a different environments. Then the adolescence is that, yeah, you start using packages. I think packages is really where you start to gain a lot of velocity and your code start to become cleaner in the sense that, yeah, you use like best practice from other developers. And then adulthood is really like you have exposure, so you have really end-to-end data engineering lifecycle handled by DBT, like from the fetching the data from the source until presenting it with exposures, and also, for instance, having hooks and hooks that work when your DBT run has finished to work. You can do like other operations not related even to DBT. Okay, good. So part 2, hands-on lab. So I'm just going to present that and put like a slide with, if you want to follow along the live coding session with me, you will have to install a few things. So yeah, so I'm going to do a 15 minutes break here, but otherwise, you can just follow along what I will be doing. That's fine. It will be quite straightforward. But if you want to repeat those actions locally, it's just have that installed. Then I will share on via the message also on the chat the GitHub repo that's public, where we will do all the manipulations. And then I think it's even better if you can do the comments at the same time with me, and you will learn even more. So I leave that page open, and I think we can see each other like at 2:35. Okay. So just a small break. 2:35. I hope you had a good break. So let's start back with the second part of this webinar, which is so we've seen a lot of theory. I hope it was not too overwhelming and that you could have a good high overview picture of what DBT does and why it's revolutionizing the modern data stack on the transformation part. So we are going to put things into practice now. So every feature that we've seen, we are going to make use of it with a simple repository. So it's the Juvo shop repository. So it's the one used by DBT. I forked it and I have added a few features on top of it, so that it's not, because the Juvo shop is quite limited. So I have added a few tests, a few packages, and so on. So that's the repo I've put into the chat that has a README and everything. So you can also, this is public, like the slide deck I will also share with you, so it can also use that at your own pace later on. So what we'll put a slide on environment setup, but environment setup is also described in the README. Also clone the repository, that will be the second step. DBT depths and DBT seeds. So we will start with that. So that's once you have a DBT project, that's the first thing you have to do. Is to install the package that you're mentioning in the package.yaml. So otherwise, DBT will throw an error and say that you have the package that are mentioned in your file, but that are not installed. In case you use seeds, well, the first thing you have to do is to materialize your seeds. Seeds are like CSV files. So these are normally in production, you would use like tables that come from an operational database, from an ingestion tool that are already there in BigQuery. In case you want to to have the data, the source data in your repository through CSV, then you can use it. So we will basically tell DBT to materialize a few CSV files that are in the repo. So that's easy for training purpose, because then you can put the data that you will use as source within the repository. DBT run and DBT build. So that will be like really running the models, running all the models that are present in the repositories. So there are not a lot of them, I think a few dozens. DBT build is actually both DBT run and DBT test. So when you run the command DBT build, it will run DBT run and DBT test together. Then we'll see like DBT test and DBT docs. We'll build new models and properties files. Then we'll also see the DBT package, elementary and DBT expectations. And if we have time, we'll go on some advanced topics, which are like GitHub Actions and how to structure your DBT project into multiple repositories. Okay, so environment setup. I hope you have all done that successfully. So you should either have an ID, PyCharm or Visual Studio Code. You should be on a version of DBT that's at least higher than 1.3, so that you have like the semantic layer. So here I've put like 1.4.1 with DBT BigQuery on 1.4.0. In our case, here for this demo, I will use Google Cloud BigQuery. So you should have access to a Google. I mean, if you want to work with this same adapter, you can really work with Snowflake or any other database. I will show you then in the code where to change that. But here I will use BigQuery as the analytical database. So for that, you need to have a gcloud installed, because gcloud is used to authenticate. So DBT will use gcloud to authenticate to your database. And then, yeah, so it will look for credentials that are located somewhere, that are located in the gcloud folder of your computer. So to do that, you have to do, as soon as you install gcloud, normally it will ask you to do an init. So you do a gcloud init, and that will save your credentials into a gcloud folder. And then you need Git in order to be able to clone the repository. So the repository is there. I've put it in the chat, so you can fork it in case you want to make pushes and do other things to this repo. Otherwise, if you just want to use it for this demo, you can just clone it. So just two variables that needs to be exported. That's the last configuration, sorry. So DBT profile. So I will show you why you need to export those variables. So DBT, there is a file called profiles.yaml. This file tells DBT how to connect, how to authenticate to your analytical database. Okay, so that's the only file that will change from one analytical database to another. You know, the rest of your code, if I'm using Snowflake or BigQuery, should be the same. But the profiles, it's really where you will have discrepancies, difference between different analytical databases. So in my case here, I have a profile for BigQuery. I'm using the OAuth method. So basically it will use my credentials, my Google credentials that are stored on my computer. And then for projects, I'm telling it, okay, where are you going to materialize all the models that I'm building here? Basically, I'm using, that's a good thing also, an environment variable. Okay, so here, basically you will need to export. That's what I'm telling you. You will need, if you want to use this repo, you will need to export that environment variable with the Google Cloud project ID that you want to use. Okay, so if you have just started with Google Cloud, you should have like a free-tier project, and you can export that variable to the project ID that was created with the creation of your project. The DBT profile DIRs, so that's the one, this file here. DBT needs to know where to look for the profiles file. Okay, so what you can do is really, if you're on Mac or Linux, you have cloned the repo, and what you can do is really use CD into DBT. That's where the profiles is located for this repository. So here you can just do export DBT profiles dir, and I will just tell it to So DBT profiles here, and then here you can just say it, your current directory. So now if I do an echo of that, I can see, okay, now my the path is correct. So now I have my GCP project. So I had done that before, but my GCP project is also well exported. So you should have those two variables. So the DBT profile here that reference the path, the full path to your profiles.yaml, and the GCP project that you will use. So in my case, it's dbt-demo-AAA. Okay. Good. So that's the only two configs that are needed. Of course, you also have to have DBT installed. So if you have cloned this repo and that you're a bit familiar with Poetry, basically that's for handling dependency management. You could just like clone this repo and then from the root run Poetry install. And then Poetry install will install all the libraries, yeah, basically DBT BigQuery and DBT core that are needed to run this. Okay. Okay, so I will go to the next slide. So first we need to start by running DBT deps. So if I go, I'm into my DBT folder, and now I will just do like DBT deps. And you will see what's going to happen here is that DBT goes, so it checks the package.yaml file here. It's going to install all the package that I've mentioned here. So as you see, the first 5 package, so this one could be without double quotes, the first 5 package are official package from DBT hubs. Every time the syntax is, the first part is who is the provider, so DBT Labs is the official DBT company. And then the second part is the package name, okay? Then you can also have package. That would be the case if you have like multiple DBT projects and you want to import those projects between each other. You would have like a Git reference. Those, for instance, are 2 packages that are not official but that are working well, that are maintained by a team, and that's but that are not published yet on the DBT hub. Okay, so by doing DBT deps, you see that, okay, it runs successfully, and then it has created an ignore package called DBT package. And here, basically, that's all the package I've just installed. So a package is just a DBT project. So if I go into DBT utils, so DBT utils, for instance, is a package that contains a lot of macros that are that can be reused, that are generic macros, so to say. And then here, if I go into macros, I can see, like, I don't know, date spine, for instance, that's a macro to generate 1 row per date. You know, you specify 2 dates, so it expects 2 arguments, start date and end date. And if you run this macro with these 2 arguments, it will generate basically, so you don't need to know about all the logic. So if you want to explore how the macro works and get some best practice, you can read this macro. But otherwise, you can just use it like via the macro, calling it like date spine and putting like start date and end date. And I'll show you actually how I'm using it here. So for instance, DBT utils, I'm using this date spine to create a table that will have 1 row per 1 row per date, and for all the year 2020. Okay, and that's really easy to use. You see, I just put DBT utils, the name of my package, date spine. I put the arguments expected, and that will then render into nice DBT to generate one row per date. So next thing we have to do is DBT seed. So as you can see here in my DBT project, I have like also a folder called seeds. So these can be seen as I told you, like CSV files that will act as the source. So really convenience for trainings like this, where we don't have like tables ingested and that we can use. So again, everything can have a property file. So here my seeds have a property files that contains like descriptions, fields, and also test. Okay, I can also test my seeds. So to materialize the seeds, so I will show you. So in BigQuery, now my project I have nothing, you know, I just have like one data set with some public data that I will use afterwards. But apart that, I have nothing in my project. So by running DBT seed, so again, easy DBT space seed. You will see that DBT will, so I have 3 seeds, and I think there is another seed in one of the packages I've installed. You will see that DBT is running the 4 seeds. And so yeah, it has like basically all the data from the CSV is now in my BigQuery. So if I go to BigQuery now, I refresh that page. I can see that I have like my seeds that are written into this data set, BQTS underscore sandbox underscore mapping. So here I will, and you see that I have my name prepended to each of the seeds, which is quite interesting. It's quite useful, because that means if we are different developers working on the same target, so like on the same DBT target, we are not going to overwrite our tables. Each one of us will have like the table with the name prepended to it. Okay. That's because why it's doing that. So 2 things here. First, we have in the profiles.yaml, we can define targets. Okay, so that's a bit an advanced use of DBT, but you can have, normally you have targets per environment. Okay, so here I have a target that's sandbox and a target that's prod. Okay, and by default, I'm telling DBT to use the sandbox target. So if I don't mention anything to DBT when I run commands, it will use the sandbox targets. So, and then you can put basically rules based on which target you are, which DBT target you are. And that's actually, if I go into one of my macros here, the macros that will be used by DBT to put the table ID, that's what I've put here. If the target name is sandbox, then you will prepend the table name with my user. Okay. Again, here I go high overview, but that's just the idea that you can really customize everything. So here I'm just like, okay, if I have this sandbox environment where I know a lot of developers will work on, well, I want to make sure that each developer has tables with his names prepended to it. If not, if I'm on the prod target, then you just write the models as is. Okay. You have the same macros because the table ID is defined by a database, by a schema, and by a table ID. Okay. So 3 things to identify a table. So that's why you have 3 macros here. So here we have the macro also to tell to which data set it should materialize. So if we take the example of the seed here, it has materialized into BQDTS underscore sandbox underscore mapping. Okay. That's because in the macro, in the DBT macro, where I put the logic in which schema to materialize, in which data set, you see that I have a rule here. If I'm running a seed, then it should go into BQGTS underscore. My target name by default is sandbox, so SBX underscore mapping. And you see that's well this data set here. It has written that. So you can put logic for any can. So you see we have put logic. Okay, if it's running the package elementary, the package project evaluator, if it's running like in sandbox, in prod, you can put any kind of rules. Same for database. So database is like we have here, for the sake of simplicity, because it's a training, we only use one Google Cloud project. You see, it's always the same project that's defined here. But you could imagine, like if you're on a big data project, you could have project per data layer, project per seeds, etc. Project for data for you monitoring and so on. Okay. So now we have run DBT seeds. So we have our source data defined and materialized here. What we can do also is DBT compile. So DBT compile basically is taking your SQL. I will do a DBT compile only on this file, for instance, the date spine here. Okay, so here it's really like it's not SQL, that is just a macro. Okay, but this macro actually behind the scene it means SQL. Okay, so DBT compile will translate DBT SQL file into SQL file that can be run by your analytical database. So here, if I do DBT compile, select, and to run a compile on only one file, you have to put the file name. So here it's date_spine. Okay, so date_spine. So this is not going to run anything against BigQuery. It's just going to locally to translate this this macro into an SQL file. So where does DBT put it? In this target folder. So in this target folder here, if I go into compiled, Astrafy DBT demo. So here I have different folders according to my package, but my package, my real DBT project is Astrafy DBT demo. You see here, I can see, okay, I have only one file compiled because I've selected only that file. You will see that this simple macro has been compiled into these results that will then, if I go in BigQuery, if I run that query, I will have one date per row for the entire year of 2020. If I run it, you see I have 365 rows. So those are things that can easily take you some time to do in SQL. Here, simple macro. So DBT compile, it's also a quick way. So what you would normally do to check if you don't have any mistakes in your DBT project, you do a DBT compile on everything. So here I've done DBT compile without a select, and then I will quickly see if my code is working fine. If you have already an error here, it means that the DBT run will not even start. Okay, so my DBT compile is finished. What I can check then, if I go into the target, I can see that in the Astrafy DBT demo, I have all my models that are compiled, like for staging customers, for my data mars, everything, okay? So if I clear that, because my models, so where your analytics engineers, data engineers will work is really in the models folder. So in DBT, you have the models folder. That's where you will define all your SQL. Okay, so if I go into staging, that's the first tables as we discussed before. If you comply with like the best practice of DBT, you will have like a data layer that's staging. That's the one that's referencing, that's starting from the source, from the raw data. In our case, that's the DBT seeds. Okay. So all my staging SQL files here are referencing my seeds. Okay, so now let's run a few things. So again, you can do a DBT run, it will run everything, but let's start with only the staging queries. And again, you can do that by selecting only specific paths. So you can do, it's like this, it's like Jaffle shop. Staging. Yeah, sorry, I'm just going to use the selectors then. Okay, that might be that I have to use it like this. So here for the, you don't want to run all your models at once. You barely want to do that because you might have a lot of models and that might not be very cost effective. So the idea is that you select only the models you want, so you can do it through the command lines, or we recommend to put it in selector. So here, basically, I have a selector that's called staging that will only run the models that are under the directories model Jaffle shop staging. So you see here model Jaffle shop staging. That's basically 1, 2, 3, 4. So I have 4 SQL files. If I do DBT run, let me clear that. If I do DBT run -- selector stg, it will basically run all the models, 4 models that are in this staging folder. And you see, so it's starting to materialize 4 models. Okay, so now if I go back to BigQuery, I refresh. And you will see that now I have a new dataset, BQTX, Sandbox, Demo, DBT, and I have my 4 staging files, okay, with my name prepended to it. And those staging files have the data from my query. Okay. So we see that here it's materialized as tables. Why? So if we go back here, so again, you can define materialization either in the config block here, but here that's not the case. We don't have any config blocks. So that means that the materialization must be defined in the dbt project.yaml, okay, the master file. So the dbt project.yaml, if we go here, we can see that for my models staging, I've put materialization, incremental, but as we haven't specified any incremental logic, it's text table, sorry. That should be table, and that's because for using an incremental, you have to define an incremental logic. If you don't have an incremental logic defined, it will materialize as a table. Just a few words on this dbt project.yaml. As I said, that's one of the master config file for dbt, so to say. So again, profiles.yaml, that's for the authentication, or dbt can authenticate. And then the dbt project YAML, that's some basic configuration for the dbt project itself. So here I'm putting the name of my project version. That's not really used by dbt. The profile, so that's very important, which profile to use. So that's in the case, my profile here is called Astrafy. That's the name of the profile here, line 7. So I put the name of the profile. This you shouldn't change. That's basically, you tell dbt where to look for the models. It's in a folder called models. I mean, you could change it, but then you should change the folder, and there's no really any, it doesn't mean anything to change that, so to say. Then the target, the clean targets, that if you run dbt clean, you will be able to clean, because every time you run dbt operations, basically dbt populates some hidden folders here, the logs, the target, and dbt package. If you do if you run dbt clean command, it will then clean all those folders and all the contents within those folders. You put also here required dbt versions for the people that will use yours. So you need to be on a version higher than 1.3.0 and lower than 2.0.0. So dbt follows semantic versioning, meaning that minor updates won't have breaking change. That's what, if you you code from 1.3.0 until 2.0.0 should behave the same. And then you can define variables. But here the one of the most important section is with the model section. Here you define configuration for your models. So for instance, here I've said that all my models have the tag demo dbt. My models under Astrafy dbt demo under Jaffel shop, they have also the tag Jaffel shop. The staging models, the documentation will be persisted into BigQuery. We can see that here. Yeah, so here there is maybe a small issue, but the persist doc, normally what it does, it brings back, but I don't think we have, maybe we don't have any documentation here. Let me check. Yeah, I don't think we have any documentation. Okay, so, well, we can do a live test then. If I do like name, customer ID, if I put description, ID of the customer, so now I've put what I expect is that this description, because I've put in my dbt project.yaml that I want the doc to be persisted back to my analytical database, then I expect this description, this first description I've put here, to be brought into my staging customer ID here as description. So we can do like dbt. I just going to run on that specific model. So select staging underscore customers. So it's going to materialize that as a table. We should see documentation being persisted as well. Okay, so completed successfully. Let me refresh. Yeah, you see ID of the customer. So now it's, and this is due to the fact that I've put a persist docs here for staging. So the staging table should be materialized, the data mart tables also. So we see here, we have defined nothing for my intermediate table. So you see, we also have like a folder called intermediate that has a few models. As we haven't defined any materialization for that, it will be a view. It will be materialized as a view, okay? By default, except if we have put a config block here. If we had put a config block here with materialized table, then again, that's what's closest to the model takes precedence. And then you can put like a configuration for seeds. That's what I have done as well. This will just put a nice color in the lineage graph for the seeds. And then I persist the docs also for the seeds. Yeah, good. So what we can do now, for instance, if I want to run, we can do that also. I can do like DBT run. Let's run everything. So this command will just go over all the models that I have in my project, but not only the models I have in my project, but also the models from the package I have imported. So here we can see like project, we can see that it's running also stuff from the DBT project evaluator, which is a package I've imported here. DBT project evaluator. So you should be careful without, with running DBT without any selectors, because that's can be quite, that can be dangerous. If you have a lot of models, it can cost a lot. That's why also you can put rules, you can put macros actually that if you run on the sandbox target, then if you run on target that's not prod, you can also say, okay, you should filter, you should only take a limit of data and not all the data. Okay, so here all my models have been materialized. So I have just one error because I'm using metrics, so DBT metrics, which is a new feature and the reference is not working properly, but now if I rerun this specific model that failed, so DBT run, select, and then example. Yeah, because this table wanted to run, but the one it depends on was not yet built. But no, it's okay. The one it depends on is built, so yeah, it runs successfully. So now we have this table. So all my DBT is now successful. If I refresh here, and I go here, I can see that I have all my tables. I have two views. Those views corresponds to my intermediate tables, okay? For which I haven't specified the materialization. So it took the view materialization by default. Okay, let's now dive into the test. So for test, I can start here. So again, you can really, if you run DBT tests, so command without any select, it will just run all the tests. I think there's quite a lot of tests defined here, but let's start granular. So in my seeds here, I've already defined some tests. You know, for instance, the raw customers, this CSV file here, I've said basically the ID should be unique and not null. The first name should be not null and the last name should be not null. How I want DBT to run those tests? Let me. So I can do like DBT test, select, config.materialize seed. So here I'm just saying it, okay, run the test on all the seeds, okay? And you will see, so basically it will run 4 tests, you know, like 2 tests here, 1 test here, and 1 test here. And we see that the test passed. So we are sure that now we are confident that the ID is unique and it doesn't contain any nulls. Same for first name and last name, they don't contain any nulls. So What has DBT done behind the scene? We can easily check that if we go to the target. Again, if you want to deep dive and see what DBT runs, you can always go into the logs or into the target. So the target logs in case it fails, target in case it runs successfully. You can go into compile. And here you can see like the schema.yaml here. That's basically the definition of my test for my seeds. That's the query it has run. Basically a test. If a test returns a row, so everything in DBT is every test in DBT is a SQL statement. So when I say in my test that the first name should not contain any null, what DBT does is select everything from the table and check if the first name is null. If there is a first name that's null, then it will return a row, and then my test will be a fail. Okay. There are two severity on DBT, so you can put either severity of warning or severity of failing. Okay, so warning, just like DBT will warn you, it will tell you, okay, this test failed, but I didn't fail the pipeline. If you put severity, by default, the severity is failing. So if a test fails, the pipeline breaks. Okay. Good. I can run also, wait, let me take other comments at, yeah, so I can run DBT tests, selector STG. So I can run also test only for my the staging table I have. And again, here I have 8 tests. It will, it's running all those tests, everything pass. Again, I can go into the target once it's finished. So yeah, pass here. Okay, so good. Compiled models. And you see here, I have not null staging customers. But an interesting one, we use also accepted values. So we wanted to make sure that a table only contained a certain field. So the field, the payment method only contained like those 4 values: credit card, coupon, bank transfer, gift card. So this is the query that that has been built to make sure that this test only contains those this field contains only those values. Good. Then what I can do then is I can also do DBT tests. So that's, it will run just a test on all my projects, but also like the package I've imported. So here I think there are a bunch of tests also on the DBT project evaluator. And a bunch of those tests will not pass, I think, because this DBT project evaluator evaluates the quality of your DBT project. Like, is all your code documented? Do you have a description for everything, etc.? And that's, as you see, I have some warning here. So and that's the case because basically not all the fields are documented. And so that's what this DBT project evaluator does. It warns you and it gives you details about it. Just wait for it to finish because the warning I quite yeah, so here it's the warning in test valid test coverage. So basically it gives you also this query, which is quite nice. So if I copy this query and I run it on BigQuery, it will be like any analytical database that you will have chosen. Like I can run that query and it will give me like quite useful information. Like, okay, I have 40 models in total. I have 41 tests in total. I have only 7 models where I've tested. So I have 17.5% of test coverage on my models, etc. Also like staging. So it gives me test coverage per models in my data layer. So staging, intermediate, marks. I can zoom a bit maybe. And so on. So it's quite this package out of the box gives you like really nice statistics and to be able for you to improve the quality of your DBT project. Okay, just checking if there are any questions here. No. Okay, feel free to ask questions. I can also like insist more or go more in details into some topics that some concepts that are not 100% clear for you. Feel free to let me know. So yeah, so continuing on test also, what important test, because here the test I've showed you is really at field level. It's really okay, checking like integrity of the data at field level. What you might want to do also is to run like unit tests to check the logic of your SQL. So here, let's say I have in my data marts, so in my models, I have my this data mart here, customers. This data mart is selecting from different like staging models, and then it's doing a few aggregations, as you can see here, and finally it's summing the amount, etc. Okay, so I want to mock. What if I want to mock some data and test like, okay, this model? I would have to mock data for customers, orders, payments, and then to be able then to test my my logic of this model. That's what the unit test here, this library that's called DBT unit testing, allows you to do. Okay, so I'm generating some, I'm mocking some data for the three tables that this customer table needs. Okay. So, and I can mock table data very easily. As you see, I can do select one. I mean, I just put like dummy values. What I want to check here is that I know that my final table, the customer lifetime value should be the sum of the amount. Okay, so that's why I put like 20. If I put 10, 10 here, the expect value should be 20. You know, and what this DBT unit test will do is like it will take as input those values, run your real customer SQL, so your logic that you have defined here, and compare it to your expected value. Okay, so that's really a unit testing. It's basic form. So you put like inputs as mocked values, and then you put what you expect, and the two should match. So if I do, the good thing here is that I've tagged this test, so I can easily run it. I can do DBT test -- select tag unit test. So this test will work fine because I'm mocking some data, and then I'm expecting the as customer ID 1 and 20 as lifetime customer lifetime value. Okay, it should be the sum of that. But we can also simulate like a fail. So if I put 30 here instead of 20, then obviously that will fail. So if I rerun that. So this is really good because it allows you to test your SQL logic, and you can run it. You don't have to run it on the full amount of data. You just mock. You can just mock a small amount of data and then run that thing. You can run it even in your continuous integration pipeline. So here you can see the test failed, and it's telling me I'm expecting 20, and I have 20 from the model that you have defined, and you are saying that you should expect 30. Okay. So here, if I put 20 back, that will run successfully. So another thing from so here we have run. So yeah, I think we can run the tests then. No, so this one we already run it, so that's fine. DBT build. So normally in production, what you want to run is really like you want to run everything at all, like but run your models, but also the test that refer to it. That's what DBT build does. So DBT build runs the seeds. So what's needed for if you have seeds, it will materialize the seeds. It will run the models, and then every time if a model has a test, it will run the tests that are linked to the model. If I do DBT build, you will see that it will run a lot because it will run all the model resource, but also all the test resources. Yeah, that's a good, very good question. So is there a way to mock data from what I would do in that case is that I would I would put the data in a seed, and then within my DBT unit test, I would then select from that seed, you know, for instance. But then here, that's a very good question actually. So how to mock data, there are quite a few packages to do that. But so the DBT unit testing, that's the package I was showing you here to mock data. So here they have mock graph, mock source. So here that's what I was using actually. So this simple example to build mock values. Yeah. So the way to go in that case, it's really, I think you would the data, the mocking data that you have, I would put it as a seed, and refer to this seed here as a mocking data. And also for the output, you would have different seeds. One for the input data so you always like unit testing a specific model, and then you would put the data that for this that this output model refers to. So this customers model needs the staging customer, staging order, staging payment. So you need to mock data for these three tables, and then the output can also be like a seed, yeah. And then you would select from that seed. Again, so here the idea is to give you a high overview, but there are really few things. That's a good thing, because through macros and the fact that DBT is really bringing like software engineering here into the game, you can really do a lot of things. I can even show you what we are doing personally on. So for instance, web analytics, we have like a DBT project for Google Analytics, and here we have unit tests, but defined with PyTest, you know. So here we really defined, we are mocking data, but in a with the PyTest library. So, and that's just a bit more like Pythonic, but you can definitely use that as well to test your data, for instance. But that's a bit out of scope. So DBT provides you already like a lot of easy to use tools. So first build in test, but also like package like DBT unit testing to do like to mock data and so on. Good. If I go back to here, so DBT build, so DBT selectors, that's what I said. So you should never run DBT like only DBT run without any select statement. And if you end up doing a lot of time the same select statement, then you should put this logic into a selectors.yaml. This selectors.yaml will contain the logic for your filtering. So for instance, here I've put 3 selectors. Sorry, I've put 4 selectors actually. So those selectors, we can go in details into them, quite easy. So their name is staging. So if I want to run this selector, I will have to do dbt run -- selector and then staging, okay? Then DBT will go into the logic and it will see, okay, I need to run all the models that are in this path. So which is models, Jaffle shop staging. I've created exactly the same selector for my intermediate models and my data mart models, okay? And then I've created a selector to run all the generic tests. By generic test, I mean all the tests that are defined directly within the YAML, okay? So for instance, the unit test, this one is not a generic test. So to say, it's more like mocking data and unit testing. So this one, if I run the selector, DBT test, selector, all generic tests, I will basically exclude that test from it. Okay. DBT source. So yeah, you can, when you do test, actually the DBT test that we have done, so was also including the, so if you go in models here, you will see that, okay, I had seeds, but I also have sources. So source, as mentioned before in the first part, is like telling DBT about the data that it doesn't know, okay? So here, what I have in my BigQuery project, I have this data set, which is called Astrafy public EU. It has 2 tables about some crypto things. So what I'm telling, so here in this YAML file, I'm telling DBT where to find this those tables. So I'm telling it, okay, the database is my Google project ID. The schema is the dataset name that you will find here, Astrafy public EU. And then I have two tables, balance and contracts. And again, those tables, I can document those tables and I can run tests on those. Okay, that's what I had here. So if I do DBT test select source crypto, here I'm just going to test if my the address field in my balance table is not null, and that's all. I just have one test here. Yeah. So yeah, it passed. DBT docs. Okay, that's perfect because I was seeing here, for instance, in my sources here, when I document, sometimes I'm not putting a hard-coded description. I'm putting a doc block. So doc blocks are really a nice way to keep your code dry in DBT because you define your documentation in a folder called docs here. Like for instance, and you can have like one, it's a MD file. So you have one MD files per, you do however you want, but the idea is that you split a bit into multiple files. So here for my sources, I've put like, is ERC20. So basically that's the doc block. And then whether this contract is an ERC20 contract. So basically when DBT will compile, we will see that in the data catalog. In the source.yaml here, you see that I've put the doc block. So, and then I can use this doc. If I propagate this is ERC20 field in other tables, I can just put this doc block and I can change the documentation only in one place instead of having to change it in multiple places. Okay. So the DBT docs, yeah, well, it's out of the box. Everything you write in your repository, DBT will use it for the docs. So, but you have to run this command. So DBT docs generates. So you see that, okay, it's running. What DBT will, what kind of, so DBT will build some artifacts, the main ones being, I'm just waiting for that to be finished. Okay. So if you go into the target folder, you will see that DBT has written like this index.html. Okay. So it has built some artifacts that can then be rendered into your browser. So if I do now DBT doc serve, you see that I have access. So that's the documentation generated by my project. So if I go on the left here, I can see the projects. So again, you will see why there are so many projects. Well, there is one project per package that you have installed, but our real project, our project is this one, Astrafy DBT demo. If we go into models, Jaffle shop, we can go into the staging, for instance, staging customers. And we can see here, like, okay, we can see that it has 3 columns, the data type about my columns. It has the test it has. So here it has like a unit test. It has a not null test applied to it. I can see which models reference this model. So the staging customer is referenced by the customer model, and the int customer order history join. It depends on the seed. So staging customer reference the raw seed. I can see my MySQL code. So that's the code I had in my PyCharm, so in my IDE, and I can see the compiled version of it. So the compiled version, that's also quite convenient. You can just copy it and run it, for instance, in BigQuery. So if I run it in BigQuery, you will see it's oh, why? Sorry. Did copy paste wrongly something. Okay, for some reason my copy paste is breaking that into multiple lines. But this code should now compile and run successfully on BigQuery. That's the compile code. Let me try if I can put it in another. Okay, so what you should do in that case, sorry, it's a BigQuery UI bug. You see, notice query runs successfully. So, and then yeah, that's an easy way to quickly debug or navigate into the results of something. Utilities, again, here, that's my date span that I showed you. So this is like a DBT utils macro from the package, but the compiled version, and you can also learn what this macro is doing behind the scene. Okay, what I wanted to show you also is that you can also write multi-line description. So if I go into models, data marts, I think that's great. I need to find it back, but models, data marts. No, here, sorry, that's here. So data mart, yeah. So basically you can have a doc block like order status, okay? That's like, yeah, that's a description that's more than one line. And you can also structure it like this, like in modern format. So this order status, I just want to make sure where is it used. Description, so it's used in the orders.yaml. So if I go into the orders here in the data catalog, I can see if I go into the description, it should be used as in the status. So if I look in the status column, yeah, you see here. So the description is really well formatted as per my multi-line. So I have like orders can be one of the following status. It's really easy to understand for anyone that wants to understand what's the status. So again, columns, reference by, depends on, and then the real code. So something really interesting as well, as I mentioned, is the lineage graph. So DBT builds for you this lineage graph. So you have you can put a bunch of selectors here. Let's select only our package. So Astrafy DBT demo, update the graph. As you can see here, on the far left, you have like the seeds and then the two tables from the source. And you can see how things, how we join together. So we have our staging tables and we have our intermediate tables. And then we end up with the data marts and the exposures. So the exposures, let me show you also that. So here in my project, if I go into my models, I have a file called exposures.yaml. This is purely informative, but that's really useful for like business users because they can see, okay, what is really like curated, what is exposed and used by downstream applications. So here I've, for instance, created an exposure that's called Jaffle board. I've put a URL, so that's basically the link to a Looker dashboard. I put the description. In the data catalog, it will appear like this. So if you go to exposures, dashboard, Jaffle orders, and then I can just, you know, there is like a few description. I can view this exposure, and that will bring me to a Looker the studio dashboard. That's broken because it was linked to tables that have disappeared, and because I've done a full refresh. But the point is that yeah, you can really link, have this like end-to-end data journey, you know, like in DBT, not just like build data marts and have those like abandoned somewhere. No, you can really like create exposures, and then your business would come here. They would see like, okay, and that they would click on it, and that would basically bring them on the URL that you have put here. Okay. Yeah, that's okay. So as I mentioned, we also have like a metric store in DBT. So this semantic layer where you can really define metrics that that can be reused by everyone. Like those metrics are not tables. They are really like You have to see that as a metric store, and you need downstream applications to be able to exploit, to use this metric store. So a lot of tools already can leverage it. But as you see, a metric is predefined. It's no SQL at all. So you define the revenue, you define how as explained already before, what's the aggregation, which dimension you can use, etc. And then people then can use that metric in their downstream application. Okay, sorry, what's the next slide? So DBT metrics and exposures. Yeah, a cool thing also is that imagine someone in this Jaffel dashboard that I just told you said it's broken, which is actually the case. So dashboard is broken and you need them to work on the models that feed these dashboards. And yeah, you need, once you're ready, you need to rerun those models. And in order to rerun only the models that depend on this exposure, you can run that. So there is a selector. So S like this is actually a select, so it's a shortcut, and then you can do like plus exposure. So everything before the models, all the models that are upstream to the exposure will run. So if I do that, so I have to kill. So the data catalog by default it runs locally on your local host, but you can host it in production somewhere else. So here you see DBT run select exposure Jaffel shop dashboard. It will run like, as we can see, 6 models. So it will rerun all the models that feed this final table, this final exposure. Good. So DBT package, as I've showed you, so that's the first thing we did. The package are defined in package.yaml. There are versions, so you put the version you want. And then you can just use those by mentioning. So for instance, in the utils, how did you use a macro from DBT utils? If you remember, went into utilities and we just did like this double curly brace. So that's Jinja thing. DBT utils, name of the package, and then the function within that package, that's fine. And then it's very easy if we go to DBT utils. So if you're working on if you think there might be a macro on there for use case you're doing, go check DBT utils, you know, like for instance here, so that's fine. I go there, I see that I can easily understand what it does, you know, the macro returns data, and you can see the different arguments it accepts, okay? And then you put it here, and then you're done. So there are other packages that we are using. So I already mentioned project evaluator. You just put it, it works behind the scenes for you when you run DBT test, and it will warn you about the quality of your DBT code, if it's well tested, if they're well documented, and so on. If you're not using sources in data mart tables, for instance, things like this. DBT expectation. So this one, I think I'm using it. Let me check. Yeah, here. So DBT expectation, it just augments, adds a lot of built-in tests on top of the DBT vanilla test. So here you can see, like, by just adding that into my YAML, in my properties, like other like DBT tests, like I put like DBT expectation that expectable row count to be between 1 and 100. Okay, so this is like a simple. This is a great test. I don't have to write the logic for that, you know. I just go into DBT expectations again. So if I go to DBT expectations, I go on the GitHub here, and I can see they have like really a lot of tests. So I can you can find your happiness most likely in those tests, and then use them. Again, you just have to install the package and 3 lines there. Then DBT will do the rest. You know, it will make sure that your table. So here it's a test at table level, that it has between 1 and 100 rows. Okay. Then what other package are we using? So, okay, DBT Labs metrics. So that was for the metric. That's actually, it will not be a package anymore because it will be included into DBT core soon. But at the moment, it's still a package. You have an official package from DBT Labs. Then elementary. So yeah, that's the one I want to focus on. So elementary gives you like a nice UI. It gives you observability on all your tests because, of course, when you run your tests through the CLI, etc., you can see it pass, but it would be nice to have like a UI to visualize those tests. That's what elementary does. So elementary, every time we run, actually, yeah, you see that at the end of each run, there is like one start hook, elementary. So again, elementary, nothing to configure. It runs behind the scenes. Every time you do a DBT run or DBT test, it will upload like data, like metadata into tables, into dedicated tables that will be used then by elementary to give you observability. So let me explain you. Let me show you, sorry. So in BigQuery, I have this data set elementary that has been automatically built. So if I look into my data sets here on the left, I can see like one data set called BQTS Sandbox Demo DBT Elementary, okay? And it contains a lot of tables, again, managed by this elementary package. Now, what's interesting is that I can like DBT docs generate and serve, I can do like EDR. So that's you have to install this elementary CLI. That's just a Python package, and then you can do EDR reports. So it will load, and then once it's ready, it will display me like a nice UI with my different DBT tests. So just give it a few seconds. And then I have like this package, like that's what the unit testing I was showing you. So this one is directly a reference. So it's a bunch of guys that have developed that on a GitHub repo. So I can easily, you can reference it. You can always reference package via Git URL. And then here there's an experimental package from DBT Labs also. So you see. And if you would have like if you would have like a data mesh structure, like multiple DBT projects, so to say, like one DBT project per data project, that's also how you would create interoperability between your different DBT projects. You would reference those. Okay, so the report is created. So look how you had nothing to do, huh? Like really like elementary had done all this for you. So we have 67 tests. 57 are passing, 10 are running. So that's the DBT project evaluator. I can easily click on it, you know, like undocumented models, like, okay, this generated, so I have 12. It gives me the query so I can get more details and so on. If I go back to my dashboards, I have 29 tables, 10 I have warnings because they have like a test that has given a warning, and so on and so on. So elementary keeps history, so it's appending every time it runs. It appends data to your table. So that means you, if you run it every day, well, you will start to have like time series with that's quite it's quite insightful. So you can have details about your test. I think, yeah. So here we can see it's mainly DBT test, but yeah. So it has also the unit test shuffle here. So you can see here, well, actually I run it, yeah, that's a good, I run it 4 times apparently. And once it failed because I had to put like the value of 30 instead of, so if I, yeah, you can see here, yeah. So that's the ID. And you also have the lineage graph here, but it's better in data catalog DBT docs. So this should be like the dashboards for analytics engineers and data engineers when DBT runs in production. You know, you go once a day or every time you want there, and you can see, okay, how are my models? Are my models passing all the tests? Is everything all right? Well, that's a single pane of glass. Okay. So elementary, that's what I told you. So it runs automatically. If you want to use the generate the report, as I told you, you have to install like elementary data. And again, the documentation of the elementary this package is really great. They're really easy to use. So you have to install two things like elementary data and then elementary data for your adapter. So in my case, it was BigQuery. And then you run EDR report and you're good to go. So project evaluator, as I told you, also like it contains a bunch of a series of tests, and that will run when you run a DBT test. DBT clean, quite useful also because as you will see every time you run DBT, DBT will populate the target folder, the logs folder, and the DBT package folder. Okay, so DBT package is when you do DBT depths. When you do DBT run, DBT test, it will populate like the logs and the target here. Sometimes you just want to clean those folders, and you do like DBT clean. Let me show you. So DBT clean, and it will, as you see, so now it has deleted those folders. So if I want to rerun DBT, I first need to do DBT depths to install my DBT package, and then I will be good to go. SQL fluff. So yeah, as I mentioned you, like SQL is very accessible. That means also that people can quickly write SQL that's not of best practice, so to say. And it's important to have a linter around it. So SQL fluff is quite the most popular one. And but yeah, it's not yet working with DBT Core 1.4. So that's why with the one, if you have installed DBT Core 1.4, it will not work. So you have to like basically revert to DBT Core 1.3.3 with DBT BigQuery 1.3.1. And then it's quite straightforward. You run SQL fluff lint. SQL fluff has also a fix feature, so you can automatically fix your SQL as well. But it's always, sometimes there are things it cannot fix. So it's always better to lint, so you have a good overview, and you pass it basically your SQL file. SQL fluff comes also, you can have a .SQL fluff configuration file. So basically, you can tell SQL fluff, okay, what rules you want to use and what rules you don't want to use, etc. Okay, and then you can put more configuration. The idea is that SQL fluff, you should run it, for instance, in your merge request, or like when you have like code from feature branch that you want to bring back to a clean branch, to a protected branch, then you should definitely run SQL fluff so that you are sure that on your main branch, on your protected branch, code has been linted and is up to your naming, to your SQL conventions. Good. I don't know if there are any questions. Otherwise, we are nearing almost to the end. I might just discuss. I might just go here on the. Yeah, feel free to ask any kind of questions here. So in DBT, so here we didn't focus too much on writing SQL. So the idea was really to show you DBT, so the framework. But obviously, the core of the framework is are the models that you write. Huh? So I can show you again. So this is just SQL, you know, like we have, of course, like the ref. So that's DBT to allow you to not have to hard code like the table ID. But here, as you can see, it's SQL. It's normal SQL. You can have config blocks also. So here I say materialize table. Alias, that's just to call, normally by default, DBT will materialize a table with the table name that has the file name, but you can tell him like, no, I want my table to be called something else than the file name, that you put alias here. So you can put macros, etc. But as you see, the SQL is basically, I mean, the core of DBT. So you code your logic is really like, it's really SQL, classical SQL. Okay. Okay. So let me go over a few advanced topics, and then I think around 4 will be done. So those are like, it's really important that, so you will, normally when you start on DBT, you will start small and then you will have one DBT project, but quickly you will get to a point where you will have like many hundreds of models, and then it becomes really difficult to manage. So that's really when you have like to split that, to create modularity. It's like one, what I recommend is like one data product, one DBT project. Okay, so let's say I can show you what we do here at Astrafy, so at our company. And again, those could be different repositories. No? So here I've one folder per data product. It's important that each folder is a DBT project. Okay, it's a unique DBT project. So for instance, I define a common macros here. And how do I use this? How do I use, for instance, a macro defining command into my FinOps data product? Well, quite easy. In that case here, I can just import it because it's in the same directory. I just import it locally, you know, like package, import this DBT project called command, you know. If this common DBT project would be on GitHub, on a public or private repo, I would just put like like I do here, like the Git revision. If your repo is private, then DBT will try to clone it using your credentials, your SSH credentials, or you will have to enter your username and password in case you mention HTTPS. Okay, so what are the goals? What are the main points of data mesh? Is really like focus on the first two, like domain ownerships and data as a product. So that's what you will achieve if you split your DBT products, your DBT project into different repos. Let me go to, yeah. So that's what I just mentioned here. Like you might have a shared, like the common. So you might have like a common data product that has like macros that can be used by many domains. And in that sense, you in the domain 1 and domain 2, you just import those. You will import this shared DBT project as a package, as I just showed you. Okay, sorry. Yeah, exactly. So that's the slide I was looking for. So as simple as exposure and source. Normally, if you want to have interoperability between two domains, so again, very easy, you can import as package, but you should only use, for instance, domain B should only consume data from domain E that are exposed, like that are really models that are the end, that are created, that are in the data mart layer, you know. The idea is that everything before that should be encapsulated and should be a part of the like internal kitchen of the data engineers and analytics engineers of domain A. You know? Domain B should only like fetch models that are curated at the end. Data ops. So yeah, I'll zoom in on that. Very important that yeah, you treat also your DBT code as something that goes through really a lot of quality checks when you merge it back to the main branch, to the master branch in your repository that must be linked, that should be linked to production. Okay, so let's say I've developed a few new models and I've tested it locally. I'm confident it's fine. Then what I do, I create a merge request on the main branch. Idea is to have like this sort of pipeline that will do like first a DBT compile. Okay, if that passes, that means there is no error in your SQL code. It will run some SQL fluff checks, making sure that your SQL code is consistent. It might run additional DBT quality checks, like making sure that all your fields have descriptions, etc. Then it should run like DBT project evaluator. This will give you a lot of warnings about DBT best practice that are not followed. Might run also DBT unit test. That's the ones where we mock data, you know, and test really like a specific SQL logic in your code. Then these two steps are quite advanced, but like data fold, data diff, it's really like if you have made a change in SQL, data fold. This data fold library will check like semantic difference. Like imagine you have multiplied the revenue by 10. Okay, so SQL wise, this is fine. You know, like you just done multiplied by 10, but that might be a big deal. You know, why you have multiplied the revenue by 10, and then data fold will highlight that. He will tell you, okay, the change that you have done, it has a great impact on the data results. You know, like in the sense that this column has everything multiplied by 10. And then you might say, okay, wow, that's not. I need to get back to the dev because this logic seems wrong. And then finally, you build a Docker image, you update DBT docs, and this Docker image, the idea is that you use it then in an orchestrator, you know, like in Airflow to. That's what I put here. The idea that this image that has been built from the merge request, you then use it in an orchestrator that will run on a schedule. So if I show you what we have here, I think I already showed you. But here, basically, we have a few data products. So we have a FinOps, mainly data products that runs every day at 10:30, I think. And it takes the new data or the new Google Cloud billing data, it does some transformation, then publish a message, and you will see that the message here, yeah, so basically that's all automated, okay? So this message then sends us an expense summary about our cost on Google Cloud for every day. So yesterday we spent like 12 Swiss franc on Google Cloud, okay? And that's well, that's a full end-to-end use case, you know, like where we have data that's generated by Google Cloud billing. We transform it using DBT. We have a data mart that will then be used by a cloud function to publish this message, to publish this Slack message. Okay, so that's the idea in production. You have like you ingest the data. You can run also like, you know, it's a big topic as well, data contracts. So a data contract is to make, because too often you have data garbage in, garbage on, and it's the responsibility of the data engineers, analytics engineers to fix that mess. And the thing is that most of the time, the data quality problems already arise from the data producers, you know, like at the database level, operational database level or application level. What you want to make sure here is that you don't start to do any kind of transformation if your data, the data that you receive is wrong here, okay? So here, what normally recommends to use, like you could already use DBT, but it's good to use like a dedicated tool, a separate tool for that. Here, Great Expectation can do really a great job. Then you run your different DBT stage. So that the dark blue here is that is exactly the same that you would run locally, okay? DBT run, select staging, etc. And then the green part is like additional stuff that you want to run. Maybe that once you have run all your transformation, you want to update some metadata in your data catalog, you want to fire a pub/sub message or Kafka message, whatever, and so on, okay? So Q&A, yeah, just checking again. I will, so the repo, you already have access to it. The slide deck, I will ask Reinhard to share it with you. If you still have questions, feel free to fire now because I still have 2-3 slides. So additional reference to pursue your DBT journey. So the DBT official documentation, really great. That's where you recognize also great open source projects, is when the documentation is really clear and straightforward. DBT free course, also like made by DBT. Really well done to jumpstart your journey on DBT. DBT at scale on Google Cloud. So yeah, I'm just doing personal advertising here. That's an article it's a series of 3 articles I've written on how to run DBT at scale on Google Cloud. And then another article I wrote like a few months back, also like some of the great package to use for all your for your DBT projects. Okay. Yeah, so watch out also, that's really cool. DBT wants to have official meetups in many countries. So they've started already in various countries in Europe. So Belgium will start the first meetup. The first DBT meetup in Belgium will be on the 23rd of March in Leuven. There will be a second meetup on the 14th of June in Ghent, where I will be a speaker actually. And I will talk about data mesh on DBT, so a dedicated session on that. Yes, so there will be like 4 meetups per year on this DBT meetup, one per quarter. It is that we change city every time. So I think the next one will be in Brussels. The third one will be in Brussels, September, October, and then we'll see after that. So Slack channel, yeah, the community is huge for DBT. I think there are more than 10,000 users on the DBT Slack workspace. There is a channel, local-Belgium. We can communicate via this through this channel. I'm active on often checking it, so feel free to join this channel, local-Belgium, and yeah, to just get the Belgium community bigger on DBT. And then please, your feedback matters a lot. I've done like a nice feedback form in type form. If you have your phone now, you can just scan that. It will take you really a few minutes, and that's really important for the future trainings that we'll give on DBT. So I can improve it in any ways. Like there is no bad feedback. So feel free to be honest. That's it. That was my last slide. I know it might have been a bit overwhelming because it's just in a few hours to cover a lot of introductory topics on DBT. I hope it gave you the sense of what the power of DBT, why it became so popular in just a few years, and the gap it's filling. So it's really like revolutionizing the transformation side of things. And yeah, I hope you will further continue to play with it and put it into production in your data project.